Welcome. It's Tuesday, September 1st, and today we're going to combine two skills, one from what you did yesterday in terms of using the signs of a trig function to figure out what quadrant you're in. And then the second part is, if you're given one of the trig functions, how do you get the rest of the trig functions? Alrighty. So what does that look like when we actually do it? So here we go. All right, this information that's on the top here is stuff that we've already done. Okay, so we've talked about what we do when the radius of a circle is something other than 1. All right, so these are not unit circles, which means even though that little 1 is there, it shouldn't be. Okay, we don't know what these radiuses are. They can be different values. It all depends on the problem. They're not necessarily 1. And so when the radius is not 1, to get your trig ratios, you have to divide by r. So instead of it just being the y-coordinate, it's the y-coordinate divided by r. The cosine is the x-coordinate divided by r, etc. All right. So here's what it's asking us to do. You're given one trig ratio. In this case, you're given sine. All right, and then from that sine, you're also told that the angle is in quadrant 2. All right, so if that sine's positive and the angle's in quadrant 2, I'm going to draw a triangle that looks like this one right here. Because that angle is in quadrant 2. Okay, so this is R. And then I'm going to make my right triangle. That's 90 degrees. And that's theta. Okay, now what you're going to do is you're going to take this information that you know about sine. Okay, the sine of an angle we already know is, in this case, 12 over 13. So what that tells us is that the r is 13. That's the radius. So I can put 13 here. Right? Then I have an x-coordinate and a y-coordinate. But I know what the y-coordinate is from the sine. The y-coordinate is 12. All right, so to get the rest of this triangle so we can fill out the rest of our ratios, we need to use the Pythagorean theorem. Or we can simply just use this formula right here, because we know what r is. R is 13. All right, so I'm going to take that formula, r equals the square root, okay, x squared, don't know it, y is 12, so I'm going to square 12. Okay, now I want to solve this. So I'm going to square both sides so I get rid of that square root sign. So I'm going to have r squared equals x squared plus 144. And sorry guys, that shouldn't be an r, that should be a 13, because that's what r is. And 13 squared is 169. Okay, then I take away 144 from both sides. And I get 25 is equal to x squared. So now I take the square root. So x is 5. All right, now here's where you got to do a little bit of thinking. This x is on the negative side of the y-axis. So the x in quadrant 2 is negative. So I'm going to write x as being negative 5. Okay, because the x in quadrant 2 is negative. All right, so this right here would be negative 5. Now I can just write out all my ratios. So my cosine is going to be x over r, so that's going to be negative 5 over 13. And my tangent is going to be y over x, so that's going to be y is 12 and x is negative 5. And then I just write my reciprocals over here, just flip them. So 13 over 12, negative 13 over 5, and negative 5 over 12. And that's it. So it's combining what we've done already. Okay, our next example. Okay, in this example, we're told that the cosine is positive. Okay. And (270 to 360), that's going to be quadrant 3. Okay, so this is telling me to draw my angle or my triangle in, I'm sorry, this would be quadrant 4, because this is 0, 90 degrees, 180 degrees, 270 degrees, 360 degrees. So we're working in quadrant 4. So I'm going to go up here and I'm going to make a triangle like this one in quadrant 4. And my angle theta starts here and goes all the way around. All right, I'm told that the cosine is 3/5. So that tells me that r is going to be 5. And the x-coordinate is 3, and now I need to get the y-coordinate. So I'm going to use my Pythagorean theorem again. So I've got r is equal to the square root. Now x I know and r I know. Okay, so this is going to be 5 is equal to x squared, so that's 3 squared plus y squared. Now I square both sides and I get 25 equals 9 plus y squared. Subtract 9, I get 16. Take the square root and I get 4. Now I'm in the fourth quadrant, and in the fourth quadrant the y-coordinate is going to be negative. So that 4 is actually going to be negative 4. Now we take those values, the y, the x, and the r, and we fill in our ratios. So y is -4, so I'm going to write this as -4, r is 5. So this is going to be -5, 4. This is going to be +5, 3. And my tangent value is going to be -4 x or y over x, and cotangent would be negative x over y. And there's my ratios. Okay, now the next two we get into the numbers. Well, I think the next one, the numbers, we end up with some radicals. All right, now what's different in here is that we're told when we look at this, we know that cosine is negative. All right, so cosine is negative in quadrant 2 and quadrant 3. When we look up here, cosine's negative, cosine's negative. Now, at the same time, you're told that tangent is positive. So tangent is positive, and it's positive in quadrant 1 and 3. So now we can deduce that the quadrant that they both share is 3, so that's where our angle is going to be. It's going to be in quadrant 3. So we're drawing this triangle now. Okay, so from our information, we know that the cosine is -1 over 4. So r is 4. And the x-coordinate is -1. Now figure out what y is. Okay, so I know 4 is equal to the square root of x squared plus y squared. Okay, square both sides, and I get 16 is 1 plus y squared. So subtract 1 from both sides, and I get 15. So when I do the square root of that, the square root of 15, I can't simplify, so I just leave it as root 15. Okay, now I got to remember I'm in the third quadrant, so the y-coordinate in the third quadrant is negative. So now we can fill in our values. So let's see, our sine is going to be negative, y is root 15, and r is 4. So our cosecant is going to be negative 4 over root 15, and I got to rationalize that. So I get -4 root 15 over 15. Secant is going to be -4 over 1, so -4. And then my tangent in quadrant 3 is positive because I get a negative root 15, I get a -1, and a negative divided by a negative is positive. Now when you flip the square root of 15, it becomes 1 over root 15. So we rationalize it. and we get root 15 over 15. And that is positive. Okay. All right, last one. Okay. Looking at this, we know that the tangent is positive. Okay, and tangent is positive in quadrants 1 and 3. Now this is telling me that the sine is less than 0, so the sine is negative. And that happens in quadrants 3 and 4. So what they have in common again is quadrant 3. So that's, I'm going to draw a picture just like example 3. All right, so if tangent is 3 over 4, then I know y is 3, x is 4. Keep in mind, I'm in quadrant 3. So the x-coordinate is negative in quadrant 3, and the y-coordinate's negative. And a negative divided by negative makes it a positive. All right, now we want to figure out what's the length of r. So r is going to be x squared plus y squared, and then we take the square root of that. So that equals 25, and the square root of 25 is 5. Now, the radiuses are always positive. You can't have a negative length for a radius. Now we just fill in our ratios. So sine in quadrant 3 is negative. So I'm going to have negative y is 3 and r is 5. Okay, flip those and I get negative 5/3. All right, x is negative 4. R is 5. And cotangent is going to be, this is going to be y, 4 over 3. 4 over 3. Okay? All right, so your assignment that goes along with this is Math Excel 15. Okay? And that's going to be due on Wednesday night, not the 2 days. Okay? I won't have a lesson for you on Wednesday, so you'll have Wednesday to do this. Okay? So just so that you know, you have the 1 day instead of the 2. But you don't have new material on Wednesday. All right, that's it. From the diner, signing off. See you next time.